All right, you ready to try one on our own? So this is a sample problem. I think it's sample problem 20.2 that's in your textbook. How to diagram a voltaic cell. So again, this has a lot of information it's asking us to provide. It says draw the diagram, show balanced equations, and then write the notation for a voltaic cell that consists of one half cell with a chromium bar and a chromium nitrate solution, another half cell with a silver bar and a silver nitrate solution, and they tell us that we've got a potassium nitrate salt bridge. Now, this is an important piece of information that they give us with this problem. We'll actually learn in our next lecture that we could have figured out who was the anode and who was the cathode, but because we haven't learned that yet, they give us a little piece of information here that tells us who's being oxidized and who's being reduced. Okay, so I want to highlight that you'll always be provided sort of a diagram. It looks like this. Okay, oops, I had some answers there. It looks like that. You'll actually be provided with that skeleton diagram, so you don't need to worry about drawing that, but you will have to label all the relative pieces. So I'm going to walk you through sort of a 3-step process here for how to do that. The first thing is we're going to label any pieces that are going to be the same for any problem. That's identifying the anode, the cathode, the direction of electron flow. And again, once you've identified the anode, you know where the oxidation half reaction occurs, and you know that that electrode is negative. Same thing for the cathode. That tells us where the reduction chemistry happens, and again, it tells us which electrode is positive. So that's always going to be the same. The next thing you need to do is you need to look at who's in solution and then break those things apart to determine your half reactions and your overall chemistry. Now this could be something that we're going to build on the skills that we had from our first lecture. Remember, we sort of had to pull apart and identify who looked like they belonged together in a half reaction. And again, we might need to have some help from information in our problem to help determine, for example, which is the oxidation and which is the reduction reaction. And what I've highlighted in blue here is that information that helps us, right? It tells us that the chromium electrode is negative relative to the silver electrode. So that tells us that chromium is where oxidation is occurring. Okay, so that's going to be an important little piece to our puzzle. Once we kind of start building up the kinds of chemistry that's going in solution, then we basically need to make sure we assign everything to the right compartments, to the right solutions, answer questions about what might be going on in solution, which electrodes getting heavier, are concentrations of this species increasing or decreasing, and so forth. So let's go ahead and start this problem. The first thing I want you to do is try to, if you were given a blank diagram, and there are blank diagrams that are available on Blackboard, you can just kind of download. It just says a voltaic cell blank diagram. Try labeling the things that are same for any problem. Where are these things going to be? So again, I'm going to pause the video periodically here, encourage you to pause it so that you can try to work through this solution. All right here. So again, anything that's going to be the same for any problem is what I've shown here in blue. Again, we know that the anode is going to be on the left. That's where oxidation occurs. This electrode is going to be negatively charged. Cathode is going to be on the right. That's where reduction occurs. This electrode will be positively charged. Electrons always flow from right to left, and I didn't draw it on here, but we could always say that anions are going to flow to the anode. Cations will flow to the cathode through our salt bridge here. And they did tell us the identity of what our salt bridge was. They did say that we've got a potassium nitrate salt bridge. So we'd know in that case that nitrate's going to flow this way, potassium's going to flow that way. So there is one other thing that we could add on this before we actually knew anything about the chemistry going on. But that kind of gets us started here. The next part is probably the most challenging because we need to think about splitting up all the pieces of information they gave into an oxidation half reaction, which will occur on the left, and a reduction half reaction that'll occur on the right. So again, they gave us some pieces of information here. They told us that the chromium chemistry is going to be occurring at the anode because they tell us that's the negative electrode. So look at the species that we have in solution, right? And see if you can figure out what the two half reactions are that are occurring in each half cell. All right here. So again, the second step is to say, all right, who is in solution? And then determine the half reactions and the overall chemistry that's happening. So again, we knew that we had chromium nitrate, we've got silver nitrate, potassium nitrate, and then obviously they told us we've got a silver electrode and a chromium electrode. So because they told us that the chromium electrode was negative, we do know now that the chromium is what's going to be in our oxidation, our anode compartment. And so if we write chemistry based on the species that we're given, we know that we have chromium 3+, and we've got chromium as a solid because that's our active electrode. Chromium going to chromium 3+ is going to lose 3 electrons. Note here, we know we can't write it this way, right? Hopefully we recognize we can't write this chemistry, even though we know the chromium electrode is on the left, and this is chromium chemistry. We know that this can't be the chemistry that happens because this is the anode compartment. Anode is where oxidation occurs, so this part can't happen. All right, so here's our oxidation half reaction. So that must mean that silver stuff is going on in the cathode compartment. All right, we know we've got a solid silver electrode, and since we know it's reduction, we know that the electrons have to be on the left side as a reactant. So that must mean silver ions from our silver nitrate solution are going to gain electrons and become silver solid. Note here, and this is where we bring in skills from our first lecture, in order to have this be a balanced chemical equation, we have to scale up the number of electrons that are gained in our reduction half reaction to match that are lost by our oxidation. So we have to scale this guy up by 3, and doing that is going to give us our balanced overall redox equation. That was one of the things that this problem also asked for, was a balanced chemical redox equation. The last thing that we want to do is label everything that's going on in here. And I want you guys to pause for a second and see if you can figure out what to label in here. All right, if this is our redox reaction that occurs in the anode compartment, so it's oxidation, that must mean, again, we know that our chromium electrode is going to be over here. We know that our chromium 3+ ions are in solution there. If we were to address some questions about how would the concentration or the masses of these be changing, the mass of this chromium electrode would be decreasing because those chromium metal atoms are becoming chromium ions. So again, the concentration of chromium is going to be increasing. Let's go over here to our silver. In our silver compartment, again, we know that our silver electrode is going to be taking silver ions, combining them with electrons to make solid silver. So that means the mass of that silver electrode is increasing. And that must mean that we're depleting silver ions from solution, so that concentration is decreasing. The last thing to sort of put in here is this concept of where are our salt ions moving. So they told us we had a potassium nitrate salt bridge. And again, you can remember that anions go to the anode, or always have a logic check. Understand why, because that way you don't need to worry about memorizing it backwards. We're going to be increasing the concentration of chromate ions in solution here, which means this is becoming more positively charged. So we need to combat that by moving more negative charge over there. On the flip side, we're decreasing the positive concentration over here because we're removing silver ions from solution, so we need to replace them with potassium ions to maintain that electrical neutrality. So the last little piece that we have up on top here has us diagramming that voltaic cell using that shorthand notation. So all it really shows is the redox active species in the correct compartments. And again, that's just going to be a way that tells us who's in which compartment. And again, we usually bracket the outsides of these with what our electrodes are. All right, so a lot of information there, but hopefully you sort of see it as a fun little puzzle to put together to figure out what does this voltaic cell look like.